slide is not applicable. Okay. Let me figure out what
Like a resounding cloud exception or something.
yes. I brought cue cards for the audience. I'm just kidding. Okay, this is my first time ever trying this whole percentage of view thing. We'll see how it works. Okay, all right. Microservices and containerization. I'm George Shaw. I'm presenting it. I'm presenting it for you guys, devICT. About the presenter. My name is George. There's my Twitter if you want to follow me. I work for Arden Labs, which is a company based out of Miami, Florida. I'm full-time remote. We specialize in Go, so inadvertently I've been exposed to things like Docker and Kubernetes a lot because they're written in Go. Some of my interests are Go, JavaScript. I'm a real big fan of React, but more so Next.js, which is a wrapper around React. Docker and Kubernetes interest me. I'm trying to get into machine learning, and I have a couple of blog posts that I've written, and I'm working on more. I really enjoy technical writing as well. What qualifies me to for you guys to listen to me? Honestly, not much. I can dunk in a 9/8 room, put that up there. But, I mean, I know a few things. Okay, so jumping into it, what is a microservice? A microservice generally serves, okay, wow. A microservice generally serves a singular purpose. And what I mean by that is if you have a user, if you have an application that also has to if an application that manages users and let's say manages files, you would split the file management part up from the user management part. And I'll get into why. Microservices are independently deployable. You can deploy one microservice without the need for the other microservices to be there in your application architecture. And I'll get into application architecture soon. They are loosely coupled, if not completely decoupled. It's okay to rely on other microservices in the architecture of your application, but you shouldn't mix functionality. If you're doing user management in one, you shouldn't have the login functionality in the other. That should be in your user management. Ideally, they're scalable both horizontally and vertically, and I'll get into more of what that means, and it's one of the main benefits of microservices. And a big thing is, and I've already kind of talked about this with the whole independently deployable and being loosely coupled or decoupled. There needs to be some isolation. You need to think about them as their own separate entities that just work together. Okay, so some of the main benefits of microservices are that they are very easy to deploy, or not very, I shouldn't say very easy, as opposed to deploying a monolith with just one big application. You can isolate some of your dependencies. Your user management microservice may need, let's say like Vault for some secrets or something like that. But that doesn't mean that your file management service needs Vault. So you don't have to worry about deploying that dependency with your file management service. You just have to worry about it with your user management. Scaling is a big thing with microservices, and it's honestly probably one of the primary reasons that microservices exist today in the way that they do. There are two types of scaling. Horizontal scaling, which is I've got people here, but they're just grabbing the screen. Horizontal scaling, which is just duplicating a service. And then there's vertical scaling, which is increasing system resources for a service that's already running, or multiple services. Another very cool feature or benefit of microservices is being able to do rolling updates. And that's generally facilitated through container orchestration software. What that means is if you want to test some new changes to your application without just pushing them out there completely, you can decide to deploy those changes, those new microservices, to 25% of your user base. See what happens there, if there's any weird bugs that pop up, and then decide to move on with the entire update. Microservices are a lot easier to maintain than monoliths. That's kind of self-explanatory. It's easier to visualize and dig into something when it's not a giant code base, as opposed to, you know, smaller, more isolated. You know what this one service accomplishes. Isolated failures are a pretty big one. So back with the whole user management, file management thing as an example application, if a user uploads a file that your service is not prepared to take on, and just call it a bug, I guess, and for some reason that causes a runtime panic and your whole program goes down. Your user management program goes down, your file management program goes down, maybe any UIs associated with that monolith, they're all down. With microservices, only that one microservice fails. It's not attached to any other processes, they're process independent of each other. Isolated failures are a very big key to why people choose to use microservices. High availability is also a very big one. If one microservice goes down, there's a chance, if you're scaling or if you're using sophisticated software like Kubernetes, another one's already up or another one will shortly come up. Geographically being highly available, if you're a giant like Amazon or YouTube and you have users from all over the world, it's almost necessary to have your services running in more than one geographic area. Your latency gets big if you're making people from Asia access servers from the United States. Microservices allow you to deploy those in different geographical locations. Designing microservices, and this is kind of the overview, and I'll get into architecture in the next slide. So before you even start, you really need to ask yourself if you need them. And I like this quote that I found by this guy who writes some books. He's really not that important, but if you can't manage building a monolith inside of a single process, what makes you think putting a network in the middle is going to help? So make sure that you have the skills to build your application the traditional way first. There's a reason it's the traditional way, because it was probably the easiest way. It is the easiest way. So get those down and actually assess the need before you just start breaking things up into microservices. A lot of people, including me, I fall for like buzzwords. I'll just, oh, this is hot in software development right now. I need to do this or I'm gonna fall behind. You don't need to feel that way, because chances are there's gonna be a new, better way to do it within the year. Another decision to keep in mind, or not decision, but I don't even know what to call it. Anyways, small businesses, with going back to the whole scaling thing, it's often the case that they don't need like a powerhouse in terms of performance, but some services need to be highly available, whether those be like emergency services. Like in the case of AccuWeather, what they do is pretty serious. If they don't get an alert out because their systems are down, that puts lives at stake. And scaling for availability is most easily facilitated through microservices, and that is also another benefit. the architecture of your entire application and what microservices do what needs to be its own microservice, how they communicate, so just the all-around architecture of a system needs to be clearly defined before you write your first line of code. Or start, if you already have a monolith and your plan is to break up the monolith into microservices, you really need to have a clearly defined architecture and plan before you start breaking things up. Because microservices can actually become a worse nightmare than a monolith if you don't have those design decisions clearly mapped out and followed. Okay, so this slide, I'm going to kind of go over the architecture decisions that you would come across as far as microservices go. So in microservices, you can think of them as modular code, functions, classes, all of those, except for daemons. Does anyone know how to pronounce that word?
Both.
Both. Daemon.
No, it's daemon.
Daemon? It is? Okay. All right.
Yeah, I've switched to daemon recently.
All right. Okay. So think of like functions and classes, but for daemons. Instead of having just one master daemon which like serves your entire application, you have multiple ones that work together, and together they serve your application. A good way about thinking about architecture for microservice applications is in layers. And I'm going to start at the most hidden layer. So if you're thinking of terms in like back end, front end, this is like deep back end or something. I don't know. So like business logic layer is what I would start with, and that might be a poorly defined term. It's my own language. But these microservices are ones that work directly with your integrated services, whether that be like a job queue like Amazon SQS or a database like Postgres or something like that. They integrate directly with those integrated services and perform all of the business logic that you need to happen to whatever data or anything like that. And then you might see a conjunction layer. It takes multiple services that are defined in that business logic layer and combines them to a more useful form as far as data goes, and maybe does a little bit more data processing or something like that. You might see an API layer. This is pretty rare. Like you kind of have to be like a Netflix or an Amazon to see an API layer, but you would see all of your route definitions, and your routes would be very simple at this point, because all of the other work happens in either one or two layers above you at this point. And this would just expose a language-independent API through like HTTP or something. And then and I had a long talk with Jacob about this today on whether or not UIs are microservices. I ended up going with yes, they probably are at this point. And you would see a UI layer. That's all I have to say about that. Okay, so there are a few pitfalls in terms of microservices. Over-modularizing, it's just like pre-optimization, my second point. Just because you think you have a need doesn't mean you have the need. So things like profiling, benchmarking, really analyzing your traffic through things like tracing. Tracing will let you know exactly where your program spends the most amount of time processing. And you can take that data and split your code up logically by that. That's the smartest thing to do. However, like you have to have an already existing application, and so it's a lot harder. It's easier said than done to tell you to go and benchmark and trace and all this stuff. So you have to give yourself a little bit of, I just blinked, sorry. It's okay to speculate. That's the word I was thinking of. It's okay to speculate on where most of your traffic is going to come from. If you have multiple services that all use the same user management pool, you're probably going to be spending a lot of time, not time, a lot of system resources on that user management section of your code. So it might be a good idea to make it into a microservice, scale it, and move on from there. So the first law of distributed computing, which I didn't know there were laws in distributed computing, but I read it in an article while I was making this slideshow, is to not distribute a system unless you need to, and I've talked about that in previous slides. Really analyze the need. If you don't need to, just don't do it. Communication between microservices, that goes back to designing the architecture of your entire application. Generally speaking, you can communicate through, most microservices communicate through HTTP and using like JSON bodies or something like that. You can also communicate through sockets. You can communicate through integrated services as like kind of a bridge, like a database or something. And those are the only examples that I wrote down. So I don't know if there's other communication methods. Deployment is something that you really need to keep in mind. If you get too complicated in your architecture, you always need to remember, like, okay, at the end of the day, I'm going to have to deploy this. And if the deployment's a nightmare, if I don't have the resources to deploy it, if I don't have people on my team that are smart enough to deploy an application that has like 14 microservices and like this and that one need to be scaled this way, what's the point? You've dug yourself a grave that you can't get out of. Another thing that you need to look out for is bottlenecks. What you need to think about when trying to find bottlenecks, if you don't already have tracing set up in your application, is which parts of my architecture do not concurrently process data no matter how many times I scale it. Most commonly, it's a database like Postgres or Mongo. They don't process concurrently. It would make no sense for them to process concurrently. It'd be dangerous. There are solutions that exist, though, that are traditional databases that can currently process within a certain means. I was going to say one more thing. Oh, about tracing. There are distributed tracing tools out there. I don't know what they are. I know that I've had talks about them with Jacob. So tracing is big. I should have talked about that in this. It didn't even dawn on me to talk about it until I got here. Tracing is really big. Okay, so now we're getting into containers, which, okay, this reminds me that there's one other thing I wanted to talk about actually before I get off the topic of microservices. Back here, I talked about isolation. I talked about it here, and I talked about it here. This whole idea of being isolated. There's layers to that isolation. So if I have a microservice and I deploy it on bare metal just as a process, that's arguably the easiest way to deploy a microservice. And I can deploy multiple microservices on the same machine, and they're all on their own process. And for the most part, it fits the definition of a microservice when you deploy it that way. You can take it one step further, and you can containerize your microservices, which isolate them even more. They don't even know about each other at that point, unless you orchestrate them correctly. And then you can take it another step further by having them containerized and running them on their own separate node. So these layers of isolation, they all add a benefit. They become easier to scale. They're more isolated. Your failures will not correlate with each other the deeper you go. But they all come at a cost of complexity. And no layer is better than another layer. You just have to analyze the situation that you're in and pick the best solution for you. And on the topic of layers, just because your environment has a lot to do with what layer you want to be on. If you need that intense isolation and the scaling options that come with having containers on nodes independently. That doesn't mean you have to do that for your development and testing environments. Your testing and development environments can be completely separate in terms of deployment on your production environment. Okay, so what is a container? According to Docker, it's a standardized unit of software. That's a pretty good definition. You could think of a package. It has everything you need in it, and if I were to give you that package, you could take and deploy this piece of software. That's basically what a container is. More specifically, it contains the following things: an operating system, the system libraries that you need to run your application, your code, or an executable, depending on how you do it, and your dependencies sometimes. Integrated services are usually like a database or SQS or Vault or something like that. They're usually packaged in a separate container and then networked to work to communicate with each other. The advantages of containers, there's a lot of advantages to containers. There's the biggest one, and the one that I appreciate the most, is, I have to write. The biggest advantage of containers, in my opinion, is how consistent they are across platforms and environments. I can give you, as long as you have the Docker runtime installed on your computer or in whatever environment it may be, testing, production, it'll run the same, it'll generate the same kind of behavior, and that's the biggest advantage in my opinion. Another huge advantage is portability, and the whole portability and container repositories thing kind of coincide. The fact that things like Docker Hub exist, or Quay, pushing and pulling, treating a deployment like a repository is an incredible thing, and I feel like it's almost underutilized in current software development. Containers also make sophisticated use of system resources, and this is opposed to things like VMs. VMs, you have to use a hypervisor, you have to install a full-on operating system, you have to decide how much of the host system's resources you're going to partition to that VM. Whereas containers, they kind of just take care of all of that for you. They make use of system resources as they need them, and they don't require full-on operating systems to be installed. They kind of play off of yours. I'm not super keen on like the deep down details of it all, but it's pretty incredible. Versioning is pretty big too, and that goes hand in hand with container repositories. Being able to version your deployments, and network security. This is an advantage and a disadvantage, as I'll get into. Most container networks, most notably Docker, they're completely locked down by default, and you have to explicitly set rules for them to communicate with each other and to communicate with the outside world of the host. So some disadvantages of containers. Initially, this slide was kind of hard for me to make, but because I couldn't think of any. But there are some. Initially, there's some added complexity. It's not like inherently, it's not common sense on how to operate Docker and what containers are and how they work together and how to version them and push and pull. You have to learn how to do that. But it isn't the worst thing in the world. And I would say that the removed complexity of deployment almost cancels this out. It's a trade-off that you have to be willing to make. Networking is a disadvantage, like I just told you, or it could be a disadvantage to you. Docker networks are completely locked down by default. If you were to just deploy a container and try and access it from your host machine without explicitly telling the container to expose that port to your host machine, you're not going to find it. Almost all of my problems with Docker have to do with networking. Like, why can't my application access the database? Oh, it's because I forgot that the host name is the service name that you define on Docker. Just small things like that, small quirks you kind of have to learn as you go, but it's not the worst thing. One of the biggest disadvantages are if you have a stateful application, and when I say stateful, I mean something that works with files, really. I don't really consider an application that integrates with a database a stateful application. The database is stateful, but the application itself is not. But if you have an application that directly writes files or anything that works with the file system, containers get drastically more complicated right at that point. Volumes have to be made use of, and which volumes make a link between the host machine and the container. So you have to make sure that you're properly managing those files on the host machine. Where is the host machine? Do we have access to the host machine? Are we going to back up those files? These are all questions that you have to face at that point. Here's just some container engines that I found. Everyone knows about Docker. Most people know about Docker. The CRI-O, this is actually cool because it's a lot harder to use than Docker, but if you need like maximum performance, this is actually a really good solution apparently. But not a lot of people need that type of performance. Rocket it used to be called Rocker. Apparently they changed it because they didn't want to be a one-letter difference from Docker. It's a CoreOS piece of software. I'm not that big of a fan of it, but it's there. And then the last two, I had no idea existed, but they're there. Intel Clear Containers and Turbo Containers. Container orchestration, there's one slide on this in here. I didn't really want to get into it that much because that's a whole topic in and of itself. Docker Compose, and this goes back to what I said about your production environment not having to be the same as your development testing environment. Docker Compose is amazing for development and testing. It's easy, it's fairly simple, and it's quick enough, and it's performant as much as you need it to be in those environments. It's not the most performant thing in the world. It's not Kubernetes, as I'm about to talk about, but it's enough for those environments. Kubernetes is very useful in production. It's also a beast. It's very complex. People spend years working on a daily basis with Kubernetes and will still tell you that they've only scratched the surface. It's a cool piece of software, but you have to know what you're getting into. It allows for things like automatically horizontally and vertically scaling your services depending upon some rules that you give it. So like if my CPU usage for this pod goes above 50%, scale it 3 more times or something like that. And then there's some wrappers around Kubernetes that make it a little bit easier to use. Amazon Web Service has one, it's called EKS. Google Cloud Platform has one too. It's I don't know if it's, I don't know why I put GCP. That just stands for Google Cloud Platform. Their wrapper is called something else, and I'm blanking on what it's called. Okay, so I'm gonna end off here with a real world example of how I might design an application with microservices and containers in a container orchestration software. So the application is NetPups. It's Netflix with dogs. I don't know if anyone remembers, Netflix used to mail you the video, so it would kind of be like that. You get a dog delivered to you, you spend like a week with it, and you send it back or something. I don't know. So some of the microservices that I think an application like this would probably use is user management, obviously. Almost every application needs user management. Like a kennel microservice that keeps track of dogs, if they're in, if they're out, their breed, I don't know. A delivery queue, a web UI, and a mobile UI. So some of the design decisions that I made and this is a very like high level architecture type thing. I didn't get into the specifics, and I'm sure that I glanced over things that I probably shouldn't have, but I did my best. So some of the decisions I made, a big one is each backend service will expose its own API. I'm not going to have an API layer like I discussed in a previous slide. That's really not necessary unless you're like a Netflix or an Amazon or something like that. Communication between microservices is going to be facilitated through HTTP using JSON bodies. It's pretty standard. You really don't see like socket communication, or sometimes you communicate through a database, but it's kind of finicky and you're just creating another area to have another bottleneck if you do that. So that's important. Another decision is that the delivery queue needs to be made highly available. I don't want there to be any downtime on the delivery queue because that halts the whole operation. People get mad if they don't get their dog by the day that they wanted the dog, and if they don't get the dog picked up on the same day. So what needs to happen with the delivery queue, if it needs to be made highly available, is maybe I will deploy it in more than one geographical location. I'll scale it in the locations that get the most use out of my service. So I live in the United States, so let's just say that it got the most use in the United States. I'll scale it a bunch in certain regions of the country. All of the microservices will be containerized using Docker. That's pretty much just like a de facto standard at this point. Not a lot of people use Rocket or that CRI-O. Kubernetes supports a bunch of container runtimes, but most people just use Docker. Integration testing in development environments, so like maybe Jenkins or something, I'll use Docker Compose to facilitate all the integration tests. I'll bring up integrated services, the application, run the test, and any sort of development manual testing will also happen with Docker Compose. I'll deploy to production using Kubernetes. And this is just an example. I really don't know how this would look, but I would just say that I would have a 2-node network to start. I'll put one node in like the center of the United States, and maybe another node in somewhere in Europe or something like that. Let me take back what I just said. Actually, let's just say this is just for the United States right now. I'll put both nodes somewhere centrally located in the United States, maybe in Kansas, because that's pretty central. And the delivery microservice will exist on its own node since it's the most important. I can devote more resources, I can scale it easier if it exists on its own node. And Kubernetes is smart enough, if that node goes down, it'll just put the delivery service on the other node, which isn't ideal, but it's better than none. And the only publicly exposed microservices will be the UIs. So the UIs can communicate with the other services on the nodes, or on the network, but the only things that are accessible outside of the container network will be the UIs. So those are all of my design decisions for like a real world example of how you would deploy an application that's built using microservices as opposed to a monolith where all of these things are in one code base. So that's what I have. It's about 33 minutes long. I expected that to last like 20 minutes, honestly. I'm glad it lasted this long, but if anyone has any questions, shoot. Casey.
Yeah, Docker Compose, can you talk a little bit about like what that does in the process? What does the preparation?
Yeah, so Docker Compose, let me think about how I want to talk about this. Container orchestration is if you have containers that all work together to create one master application, it's very difficult to independently manage those. It's almost impossible too to make a secure network when you're independently managing those. if you use a container orchestration software like Docker Compose, you define all the services in one file, and you tell through this configuration file, you tell each container, okay, on this Docker Compose network, I want this service to map its own port to the network for the I'm trying to basically what a container orchestration software does is it allows your services to communicate with each other through rules that you define yourself. It does a lot more than that. Like container orchestration software is ultimately what handles scaling and being available and all of that. But one of its most important things is networking those containers.
Would you consider there to be value in taking a monolith and just knocking one microservice off of it with a pickaxe? Like, just get one microservice out, and then maybe next year you get another one, or would you say you just maintain the monolith at that point?
No, that's actually completely fine. Like, that's a completely okay use case for microservices. If only one part of your application is experiencing just like an immense amount of processing and time spent in that specific area of your monolith, breaking that off into a microservice and allowing just that section to scale is completely not only fine, encouraged. There's no point in breaking apart the other parts if you're not going to get any performance or availability benefits out of it.
Cool. Another thing, have you worked on a project where the architecture was decided on in advance and then you actually continued on with that same architecture? You said that was important.
It is important. It is important, and
we just redefined the architecture for project yesterday.
It is important, and that's just one of those things that I'm going to sit up here and tell you to do it, but because if I told you not to do it, then what is this guy talking about? Yeah, you're right.
Okay, we have to pay lip service to this idea. Cool.
Yeah.
Well, like I say, at least maybe the idea is you have one, right? Because I've been on a couple projects at work where we didn't have an architecture, and I'm just coding away.
And that's dangerous.
Right, it's very dangerous, and you can't make microservices. Like I can make you an API, guys, but I can't. No, because we don't. It's a monolith at best.
Better to have one and change it than not have one.
Yeah, if you don't have one, you don't even know what you're tying together, and you just.
You said that you were going to explain what you meant by horizontal and vertical.
Oh, yeah. I thought I did, but I guess I didn't. Okay, so horizontal scaling, and this is in terms of microservices and containers. It means a completely separate thing in terms of IT, like in the IT world, I guess. In terms of microservices and containers, though, horizontally scaling refers to duplicating your microservice multiple times. And there's in container orchestration software like Kubernetes, there's services that deal with routing that traffic efficiently. So it's not going to dump all of your traffic into one microservice. It's going to split it efficiently. And if you duplicate it 4 times and you get 8 requests, ideally 2 requests per microservice. That's what it'll experience. Vertical scaling refers to giving a node, or not a node, well, a node, sure, which is an analog term for machine in a network, more system resources, and you can also allocate more resources to a container on a node, which is also vertical scaling, maybe. I might just be saying that though. But that's what it refers to. Vertical scaling refers to system resources, horizontal refers to duplicating your microservice or container. Any other questions?
Do you know when you vertically scale versus horizontally scale a service?
I'm not going to sit up here and tell you that I do. But that's a DevOps thing. I don't know.
You mentioned the database scaling now. That'd probably be a pretty good example of where it's a little bit easier to vertically scale. Versus
Yeah.
like a web server or something.
Yeah, so at the last presentation I gave, it was over Kubernetes, and I talked about like database and how you would scale that. And honestly, the answer is, horizontally at least, you don't, because you can't. If you horizontally scale a database, it's a stateful application. A user may exist in one instance where it doesn't exist in the other, but you can't. Yeah, you would just have to vertically scale a Postgres database or a Mongo database.
You can, but it's hard.
Well,
Yeah,
it's another-
You just have to sync.
You're actually, yeah, you're right, because you can use volumes too.
You
Yeah.
have like multiple slaves that all sync with a master. You can have multiple. We used multiple master call cap for a little while, and it's difficult, but eventually things all kind of get into the right place.
Yeah.
But it's like a different product, right? I mean, multi-master in SQL is like, that's not Docker containers, it's another.
Say what?
Do you use Docker containers then to deploy your different?
We were on AWS, so
Okay.
it's, I don't know how you would integrate it
Yeah.
with Docker, but
I was just thinking, horizontally scaling databases is like basically another database product, typically. Like,
Called backup.
Probably.
well, I mean, MySQL has a way to do it. Oracle will sell you lots of ways to do it, very
Oh,
expensive,
sure.
you know, and then you can have a lot, as many servers as you want. But
And I don't even know, I would have to see like the benchmarks on it, but I would be curious to see if horizontally scaling a traditional database like Postgres would even offer much benefit, because I don't know where most of the processing time gets spent. I don't know if it's in the actual, because I don't think you could probably safely concurrently process most queries, because a query could be updating the same piece of data that's being deleted at the same time, and I don't know. It would be cute. I'd be curious to see how all that worked out.
Oracle Rack, that's what they call it.
Is that
Right,
their concurrent database
Yeah,
model? Or?
yeah, and you run as many systems as you want, and they spread it, and it's one thing.
Really?
But I mean, it's like black box kind of stuff, as far as I
Oh,
know.
yeah.
You know, you buy it, you plug it in, and
And it
it
just
works.
works.
Yeah, I mean, you know, it's paid software, it's something else.
Yeah.
To me, that's how you horizontally scale databases.
Yeah. Yeah.
In some ways, I would think that the microservices thing is actually catching up with what some of those things do. Like Oracle has been, you know, splitting out your databases in multiple systems for years now.
Yeah.
But it was a very they could control everything about it in software, as opposed to like writing your own software that understands that.
Yeah. I read somewhere while I was doing the research for this presentation that the term microservices was coined by an author in 2008, and then it was brought up for the first time at a software conference in 2011. So this is a fairly new thing, I guess. But yeah, you're right. Like companies like Oracle have probably been doing this since the early 2000s. They
Yeah.
just didn't have the term for it, or this wasn't the term.
And with very specific things like the
Yeah,
database,
exactly.
or the file system.
Yeah.
Veritas has, you can take your file system and split it up. I don't know
Yeah.
how they do it, but they do it.
Magic.
Yeah, it's magic. But it's just one little thing, it's not your custom application.
Any other questions?